Hello all, I'm Naga Kattula. As the presentation title states, Building Resilient Machine Learning Cloud Integrations, a practical guide to secure, scalable, and cross-platform architectures. Today we'll be seeing the robust practical guide for machine learning infrastructures that we have in place. Very first slide is talking about multi-cloud reality. What exactly is multi-cloud? Machine learning is very much evolving in today's world, as we all know. And to deploy machine learning solutions, all the companies are widely using 3 plus cloud services. So it could be 2 plus, it could be 1 plus, but it is a multi cloud, I would say, overall. So using these multi cloud solutions or cloud deployment models definitely has an advantage. The very first advantage is that we were able to get over vendor lock-in. So vendor lock-in is no longer happening. That's great. But what is the con of this multiple cloud services that we are incorporating into? Very firstly, operational efficiency. How are we going to operate the instances of all these clouds? And also we will be running into issues around compliance and data security and privacy. The overall spendings into the cloud by 2028 is going to cross 1 trillion. Just imagine that 10,000 companies are today trying to invest into multiple clouds. Like 10,000 into 3 is already 30,000, and each of them pays their amount depending on the scale of their solutions that they have in place. That is like a lot, to be honest. And when we are trying to spend a lot, I think we have to make sure that whatever we try to spend is worthy, it's deployed in a right way, and the architecture is all laid in the correct manner. And overall, today's percentage is crossing 75%. So exactly, to be more precise, it is 78%. So we have many ML deployments that are taking place across multiple clouds and not through a single cloud. Let's move on. Let's take a look at cloud deployment models. What all models do we have in place? We have infrastructure, we have platform, and we have software as a service. So all these cloud models are widely used for different purposes, and mostly infrastructure means that they have virtual machines and networks for complete control over machine learning environments. So this is best for custom frameworks and specialized workloads. And one of the major example in this area is AWS EC2, how they are going to give all the machine learning solutions, right? And platform as a service. For platform as a service, we have AWS SageMaker in place, which is a good example, and also IBM Watson Studio, along with Azure ML and Google Vertex AI. So this is very much useful for development teams to focus on model creation. Mostly we'll be having all the ML frameworks as managed, so we don't have to really worry about building something from scratch because we already have all the built-in scaling that is enabled for us. Software as a service. Software as a service is something, so it is using minimal configuration. So it is definitely perfect for specific use cases. For example, AWS Recognition and Azure Cognitive Services and Google Vision AI are providing a very good service in this area. So all this minimal configuration means that you can just drag and drop most of the components which are out of box in nature and already built. Nextly, ML API integration procedures. Today, we have a lot of procedures that we are following. One is REST API. So REST API is a very robust API. It can be very much used by mobiles and it's super lightweight. It is stateless architecture and all the endpoints or all the callouts are made on a HTTP based endpoint. So it is definitely secure, and also JSON and XML responses are all accepted. That means that it can work with wide architectures and it can work very easily with third-party APIs and third-party coding frameworks as well. Nextly, GraphQL. So GraphQL is definitely growing. It also has principles which are similar to REST API, and the flexible data queries option is available in GraphQL. So data retrieval will be very much precise, and also It is stateless, and we'll still have a single endpoint. And the very much advantage of GraphQL is that it has reduced the overfetching limit, right? So you don't have to overfetch the data. It is taking care of all the data and giving us the right data we need, and also it is processing machine learning in the right way. So this GraphQL has been recently integrated with Salesforce. Salesforce is one of the software as a service platform, and it is mostly used on the JavaScript side of things, and it is very much robust in connecting to the server and getting all the data that we need. Nextly, gRPC. It is a high performance binary communication integration approach that we take, and mostly it will help us with the streaming support that we need, and also the latency is very low, making it very advantage for handling large volumes of data. And last but not least is event driven. This is very much required to make sure that all the asynchronous machine learning are processing at scale, because it handles super large data volumes, millions and billions of data. And also one of the major example in this area is publish subscribe pattern, queue based processing, which is asynchronous in nature, and also we do have serverless triggers, which is more advantageous. So by using the right API procedures, we can definitely improve the efficiency of overall model. And nextly, identity and access management. We were talking about security breaches and potential issues around identity. So this model has a pyramid shown here in the image, and from bottom to top, if you can look at it, the top is having least privilege access. That means you're minimizing all the permissions to what's absolutely necessary only. So least privilege access is mostly preferred, and multi-factor authentication and role-based and centralized identity, all of these factors should be considered when we are designing a model. The implementations with organizations with implementations of IAM definitely will be reporting less than 50% breach cost. So we just need to implement it in a right way. And I think that role based, multi factor, and centralized identity. So, for example, your resellers can definitely get a centralized identity and multi factor authentication. But how a guest user is trying to access the application or overall model is where the issue comes from. We have to manage it depending on the type of the user who is trying to access the application. And nextly, zero trust security model. That means do not trust. Just keep validating and validating every time you try to make a trust to, it could be to a person or it could be to other device. So firstly, yes, verify identity. Authenticate every user and service accessing ML resources. That's very much necessary. And nextly, you have to validate the device as we discussed. So keep checking the device. It could be via any kind of authentication practices that we discussed in the past slide. And limit access. Just provide just in time, just enough permissions. Usually for limiting access, we also have many handlers in place that we can use in the models. We can incorporate them. And nextly, monitor activity. So continuously do a event monitoring to analyze the behavior for anomalies, analyze the behavior for fraud detection, and also anomalize it for most of the issues related to duplicates. So all these anomalies need to be identified in a right manner, and at every step I would strongly recommend us to have monitoring activity. It could be via interactive dashboard, it could be via report, but this is very much necessary, and most of the platforms are also providing this out of box, which we can leverage. I think zero trust definitely eliminates the implicit trust from machine learning architectures. Every request must be verified regardless of source. And training data protection. This is very much vital for us to get rid of all the privacy concerns that especially we have in place. So end-to-end encryption is very much needed. So we have to make sure all the ML data in transit, at rest, and in use is encrypted correctly. So we have to include all the key rotation, we have to include all the SHA keys, SHA keys, all the encryption practices in place, and where much as much as we can try to, and also keep it secure via key, authenticated key. And data sovereignty controls. So mostly we have to respect the geographical data restrictions through regional storage. We have to implement cross-border transfer mechanisms whenever necessary. And dataset access monitoring. We have to track all the interactions with training data. Implement alerting for unusual access patterns that might indicate data leakage. Data leakage can happen at any point of time if we do not have proper dataset access monitoring techniques laid in place. Differential privacy, we have to add a statistical noise to protect individual records. Balance privacy with accuracy needs for sensitive ML applications. This will also be indicating that we need to have the proper IAM mechanisms in place. And nextly, compliance. We spoke about compliance issues that today's world is facing, and why is this happening? Because with the cross cloud architecture we have in place, we are facing HIPAA concerns, we are facing GDPR compliance affect EU, PCI, and CCPA. So all these laws are legal and ethical, and all the ML architectures that we are developing should comply with each of these laws. So GDPR is mostly data subject rights and AI transparency requirements that affect the model design. And HIPAA is mostly healthcare. Each of us will be signing a HIPAA consent when we go to a doctor. So all the HIPAA consent practices should be laid in our infrastructure, and platform should be encrypted. We have to use shield platform encryption, and we have to use other encryption techniques that are available for us to encrypt all the data and make sure that what is available and what is not available depending on the type of the users. EU AI Act is a risk-based approach to regulating ML systems by application, and the payment, secure handling of financial data used in fraud detection models, that we need that model. And also the CCPA, right? Consumer rights to data access and deletion impact training process. So all these considerations have to be considered. And nextly, cost optimization strategies. Because we are spending a lot, what are we really trying to do in terms of optimizations? So leverage all these spot instances. So that means we have to make sure all the non-critical training job on discounted compute. You just have to defer all the computations of non-critical training jobs to make sure that we will be using spot instances. And nextly, we have to optimize the storage tiers, meaning if your training data is not accessing any data frequently, then you have to move it to a cold storage. And also auto scaling, meaning we have to scale the resources based on prediction demand. That's very much vital. And right size compute resources. Match instance types to ML workload needs. You just don't need it oversized, but you want it to have it in a right size so that you will be saving on all the space complexities that we'll be having. And properly configured ML environments can reduce the cloud spending by 30 to 40%, which is a lot. And also regular cost audits should be taken place, so that we will discuss all the optimizations with them, and we can always try to optimize as much as we can if we are missing on anything. Cross-platform model service, containerization. So package ML models and dependencies for consistent deployment anywhere. One of the example is Docker and Kubernetes, because they are already providing platform agnostic or orchestration. Next is serverless inference. Deploy models and functions that automatically scale with demand. And also we only pay for actual prediction time with minimal management overhead. Lastly, we'll be discussing about model versioning and performance monitoring. Performance monitoring is, again, we have to track all the model metrics consistently across multiple cloud providers. And related to versioning, We have to implement all the releases for a safe model updates in ignorance platforms and real-time machine learning integration patterns. So, what are the integration patterns that we have in place? Synchronous API, synchronous processing, and stream processing. Synchronous API example is again REST. We could think of it as just using a REST API in place. So direct request response pattern for immediate prediction. That means you will you will fetch, wait, and get the response and show it back to the user. So the latency is very less, under 100 ms. And asynchronous processing, this could be event driven architecture mostly, where we'll be using queue based inference for high throughput workloads, ideal for batch predictions and background processing, scales easily during peak demands. And nextly, stream processing, that is a continuous inference on data streams. So you keep streaming the data and you keep receiving, and the people can subscribe and they can hear the real time data from us. Disaster recovery. This is very much needed. What exactly is a disaster recovery? Let's say we have a natural calamity or immediate power interruption. What are we going to do? So, disasters are something even more bigger than power interruption. Like I mentioned, it could be a calamity or it could be even more a system failure altogether, right? What we have to make sure all the models have these strategies incorporated. So model registry replication, that is where you automate all registry synchronization, implement cross region validation, which is more required. What if other region fails and one region is up? And also version control all model artifacts. You can use any GitHub, you can use Bitbucket, and also other source controls and version controls that we have today in place. Multi-region deployment, using global load balances, which is very much vital for a right model, and implementing health checks as required, and test regional isolations regularly. Health checks are mostly part of many of the software as a service platforms. They have out of box health checks that we can leverage, but if we do not have one, we have to make sure we'll build one depending on the org requirement. And degraded operation modes, right? So we have to develop simplified fallback models, meaning you can build a dead letter queue, you can build a retry mechanism, but that is more important. And also cache recent predictions and creating rules based alternatives. You just need to make sure how you redirect your queue to, or how you are going to redirect your model to. That's more vital for the machine learning system to work in a right way, and that represents the cleaner design. And also the key takeaways are, we have discussed about training databases, we have discussed about how engineer resilient cloud integrations through API architectures and also through IAM protocols. Implement comprehensive safeguard for training data while navigating complex compliance requirements across multiple regions. And also we have to architect our systems to built in with scalability, and we have to make sure that cost optimization strategies are in place, and also the disaster recovery mechanisms, which includes dead letter queues and more, to ensure operational continuity. That's mostly about my presentation, and thank you all for your patience today. I really enjoyed talking in the conference. Thank you all.